This problem is asking us to come up with a sine function in the form of an equation that represents a situation. So to start, it says there's a musical tone known as middle A that completes one cycle in 144 centimeters, and this is the equation that it represents. We just need to change this so that the cycle is now 150 centimeters. So that means I'm going to keep everything as is. I'm going to write y equals, I'm going to rewrite sine of something times theta, right? Now, originally, you have a b here, and that b represents how many cycles from 0 to 2 pi are completed. But now, if the cycle changes to 150, we need to switch up that value for b. So the formula for the length of one cycle is denoted by p, which equals 2 pi over b. So again, p, which is a period, the length of one cycle, will equal 2 pi divided by b. So my new period or cycle length is 150. That's going to be equal to 2 pi over b. And now I got to solve this. So let's get rid of this fraction. So to do that, I multiply it by b over 1. So b over b will cancel out. I have to multiply the left side by b as well. So I'm left with b times 150, which equals 2 pi. Now I have to undo the multiplication here. So I divide both sides by 150. So now b will be whatever 2 reduced by, or well, 2 divided by 150 is. And we could reduce both by 2 to give us our answer. That means I'm left with pi divided by 75. So that's going to be plugged in for b, which means my new equation will be y equals sine of pi over 75 times theta. And that's going to be my answer. This question is asking us to write a function in terms of time. So what we have is a low tide that starts at 9:30. So this is kind of wrong. Not kind of, it is wrong. That's 9:30 a.m. and then this is going to be 9:30 p.m. So low tide begins at 9:30 a.m. It ends at 9:30 p.m. The length of one cycle then is going to be 12 hours. It says that the difference in water level is 40 inches. So this graph is also slightly wrong. If it differs by 40 inches, the top part to the bottom part should be 40. So if I cut that in half, from the middle to the top part, that's going to be 20. And then the middle down to the bottom part, that's going to be 20 as well. So it should really kind of start there and then go up and kind of top out right here at 20. And then go back all the way down so that it bottoms out again at 20. So slightly off, but back to creating my equation. So I have a cosine function that I need to do, and that says that in the problem. So I'm going to start off with y equals, it's cosine, but I need to put something in front of it. Now, because my graph starts below the midline, which is right here, I have to make it a negative because it's starting below the midline. Now, the distance from the midline to the bottom of my graph is 20, right? And then from my midline to the top of my graph right here is 20. So that means I need to put my amplitude, or my A value, as 20 there. And now it's just a matter of putting a number in front of t. Usually that's theta, but we're gonna use t for time. We need to put our number here for b. So remember, the equation that involves b is p equals 2 pi over b. And remember, p is a period, or the length of one cycle. That was 12 hours, we said. So that's going to be 12 equals 2 pi over b. And then we got to solve this just like we did in our other equation. So, or my last problem. So I multiply both sides by b. So I'm left with b times 12, which will equal 2 pi. Now I have to undo this left side by 12, so instead of multiplying by 12, I'm going to divide by 12. I divide this side by 12 as well, so b will be 2 divided by 12 reduces to be 1 over 6. And don't forget to keep pi up there. So now I'm going to move pi over 6 up here to be my value for b in my equation, and that's going to be my final answer.